Hello, and welcome to this comprehensive tutorial. Before we dive into the line of code, let's quickly understand what RAG is and why it's radical, revolutionizing how we build AI applications. RAG, or Retrieval Augmented Generation, combines the power of LLMs with the ability to retrieve specific information from your own data sources. This solves one of the biggest limitations of LLMs, i.e., their inability to access your proprietary data or the most up-to-date information. How does that work at a high level? Your documents are processed and stored in a vector database, and when a user asks a question, the system finds the most relevant information. This relevant context is sent to the LLM along with the question, and the LLM generates an answer based on both the question and the retrieved context. This approach gives you the best of both worlds, the reasoning capabilities of LLMs combined with accurate, up-to-date information from your data. Now, let's talk about Langflow. Let's move on to creating our flow. So, open the application here, create a new flow, and I'm going to create a blank flow. We're primarily working with two flows, two parallel flows, which are the load flow data, where we prepare and store our documents in a vector database, and then the retrieval flow that will set up the system to answer questions based on our stored data. For this application, we're going to use a file loader and a vector store. We have a couple of options here, but for this tutorial, we're going to use files for our vector store. We will also use our model. For this particular tutorial, we're going to use Cohere, which is an AI model. We'll go into how to create an account and get your key. We'll also be using a parser for processing. I'm going to use a parser for this tutorial. Remember, our flows are in two parallel forms, a load data flow and then a retriever flow. For each flow, you can add notes and adjust the size. So, we will have our retrieval flow here and the load data flow here. I can change the color of this. Everything is being replaced now. We can go ahead to create the load data flow to process and ingest documents, and after that, we build our retrieval flow to answer questions based on the data. Then we test, find our raw system, and look at advanced techniques to improve response quality. As I said, we need a Cohere API and a breakout. This flow will help us process our documents and store them in a database. Let's start by setting up our environment. The first thing we need is a Cohere API key. So, head to your browser, search for Cohere, go to your dashboard, and then select API keys. You get free trial keys. Although this track is already loaded with a key, they can be used for this tutorial, but not for commercial purposes. You can create a new trial key, generate the trial key, then copy and save it somewhere, because once you close this, you don't get access to it again. Go back to Langflow, and now we can go ahead to build our components. Let's create a file now, which will have several components. The first component is our file loader component. Alright, so we zoom out, then go to Settings, then Global Variables. We're going to add a new variable. We're going to copy the API key. Go ahead, API, because it's the best to store your keys safely without exposing them. Paste it here, then save the variable and go back to our flow. We have a Cohere API key available. After our file component, which loads our file, we're going to need a text splitter. So select text splitter from here. You can configure the chunk size and the chunk overlap. We're also going to need an embedding tool. Of course, we're using Cohere, so select Cohere embeddings. Now we'll use our vector store. There are a couple of options here. You can use AstraDB, but for this tutorial, we're going to use files. You can declare your directory. You can just use our directory, which basically defines any directory in your local system. Now we are going to connect these components. Connect the data to the text splitter. Then the chunks go to the ingest data. Your embeddings go to the embedder. We're going to use our global variable for the Cohere API key. Then select your file. We're going to use our leadership file, select the file. Now we can run this component. You'll see that our files and vectors have been built successfully. Notice the time it took for the file component and the embedding component to process the full text in the file. What this means is that our document has been split into chunks and stored in a vector store called files using Cohere Embeddings version 2.0. To understand what's happening in this flow, We upload a file, the components process the content, and it's sent to our file's vector database. The Cohere embedding controller generates vector embeddings for the text. Then, the vector store stores both the text and embeddings in the vector database. This is the foundation of our RAG system, creating a searchable knowledge base for our document. We've already tested this flow by uploading a sample document, and everything is configured correctly. As you can see, the document has been processed and ingested. There are now 5 records. So that is it for setting up our data flow. We set up our logical flows and processing store. Now we'll create a retrieval flow that allows us to ask questions and get answers based on our stored knowledge. We're creating a flow, a retrieval flow, and this flow will be more complex than our logical flow because it involves taking user questions as input, retrieving relevant information from our vector database, formatting this information for our language models, and generating a response based on the retrieved context. We'll start by adding the message component from the sidebar. This time, we use the input of the chat input, and we're going to expand this so the chat input takes the user question as an object. Now we want our vector store, which uses the files. So let's adjust this here to make it more organized. We also need a parser component to format the retrieved information. So this time, we're using a parser component. And we need the current component to structure our queries. Now we come to select point, and then we need an LLM to align to this model. We'll select the model under our models. I'm going to select the Cohere model. Then we need a chat output to display our answer, which will also expand. Now we have the needed components. I'm going to configure our components. We also need an embedding component, our Kubernetes embedding. Quickly, I want to connect our message to our search query. This message is going to search our vector database. Remember, our query API is a non-global variable, so we select it, then connect embeddings to embedding. Sorry, we selected the wrong API earlier. It's supposed to be the Cohere API key. Our persistent directory is the same directory on our C drive. We connect our data frame to data here. For our parser component, we use the parser which formats or converts extracted data from the files into a readable format, not the language model. Now, let's go to our prompt component. This is where we structure how the retrieved information is presented to the language model. I'm going to create a template like this. You are given the context below to answer the questions as best as possible. Now, context is equal to our variable from the arrow, which is context, and our question has to be equal to our variable question. Then we add answer to the question as best as possible. And then we also add answer. Check and save. This format clearly separates the retrieved content for the user's question. We connect parse text to context, and I also want to connect our message to the question. So the message from our chat input in the playground is connected to the question. For Cohere, our Cohere account message goes into input, and we select our Cohere API key from the global variables. Our message output is connected to display output. That's it for the setup. We have connected our chat input to the files database search query input, the files data frame connected to the parser data input, and the parser parse text output connected to the prompt context. The chat input message is connected to the question input for the prompt message connected to the AI's model input, and the AI model's message output connected to our chat output. Let's walk through how this flow works step by step. The user enters a question in the chat input, which is sent to files as a search query. The search finds the most relevant documents using vector similarity search. The parser converts these results into a readable format, and the prompt combines the retrieved context with the original question. Then, Cohere generates a response based on the context and the question. The chat app displays the final answer to the user. This is the essence of RAG, retrieving relevant information and using it to augment the large language model's response. That's it for our retrieval flow. We are going to test our RAG application to check if our flow is working correctly. Let's test our flow by asking a question related to the document we uploaded earlier. Remember, we typed the question, "What is the document about?" When you go to the playground now, we just hit enter, and we see that the system fetches relevant information from our database and uses it to generate a response. This answer is specific to our document rather than relying on the model's general knowledge. The document is a list of references on global value-based approaches in various contexts, including organizational behavior, etc. We see our leadership-based body, PDF, and that is an article about leadership. So we have a correct response from our RAG application. That's it for building our RAG application. One key optimization you can do is adjust the chunk size and also the overlap. The chunk size controls how large each text chunk should be. Around 1,000 tokens is often a good balance. The chunk overlap allows overlapping between chunks to preserve content context. Setting this to 200 ensures that concept spanning chunk boundaries are not lost. Your separator specifies how to split your text naturally, like by paragraphs. Another thing we can do is modify our prompt statement. For example, we can say, given the following context from the content below, answer the user's question as best as possible. If the information isn't present in the context, say you don't know. We can now test this enhanced flow with the same question or a new one. We can even try the same question again. Let's play around and ask, what is this document about? Let's see if it changes anything. The answer is principally the same. For relevance, you want to ask questions directly related to your document. When evaluating an RAG system, you look for relevance, accuracy, completeness, and hallucination. Are the answers directly related to the question? Is the information correct? Accuracy? Does it provide a full answer? Completeness? Does it make up information or interpret things that aren't in the context? Hallucination? For example, let's ask, what is love? Which is not in the context. Let's see how our application responds. You see it says, the provided context does not contain information about the concept. Therefore, I do not have information to answer the question, what is love, based on the given text. So the RAG application is free of hallucination here. Now let's ask, what is leadership? It should give us an answer based on the document provided. We see that leadership, as described in the context, is based on this. This answer directly comes from our document, which means that when analyzing or evaluating an RAG system, we see that this RAG application works well. Another thing is that Langflow allows us to see what happens at each step of our flow. You can just click on this and see. And Langflow also gives us the time taken for each component to process or how long the process takes for each component. You can also try using other vector stores like AstraDB, Cassandra, or even a local DB or Redis for your RAG applications. I hope you have learned how to create RAG applications using Langflow. You can publish your application as well, either through API access, MCP server, or embedded sites. Thank you very much, and I'll see you in the next tutorial.